Hey, good morning, Math 8 students. Today's con requires a little thinking, not horribly difficult. If you pay attention to this video, you should be able to make it through. But it also requires you to have some prior knowledge from things we've talked about in the past. So I'm going to go through. You can see I've got three examples here. I've got example 1 right here. I've got example 2 right here, and I've got example 3 right here. So we're going to do 3 examples of this. There's 3 different answers you're going to get on this one. One of them will be an exactly one solution, one will be a no solution, and one will be an infinite solution. So I want you to be able to see what that looks like graphing wise. So I have one of each on there. So whenever you're given equations in this form, this form is called standard form. Well, you'll notice the x's and the y's are on the same side of the equation, and they only have a number on the other side. Well, the fact is, when we're graphing, we don't want it in this form. We actually want it in y equals mx plus b form, like example number 2 is. So what that means is we have to solve for y, get y by itself. So you've done this before. This is part of that prior knowledge. You should know how to do this, where you would get rid of the positive 4x by subtracting 4x. And then after you do that, then you would divide both sides by 2. So when you do this work, these two answers would come out to be y equals 2x minus 4 for this first equation. And the second equation would come out to be y equals negative 2x plus 3. Wow, did I say plus 3 on that? That was not smart of me, and I can't change it right now. It should not be plus 3, it should be plus 2. I don't know why I did that. So actually, I'm going to change that right now. So hopefully if you did that, you got plus 2. I just typed a 2 on here somewhere. There it is. I'm just going to put that 2, big old 2 right on top of that 3 there. And we're going to make that nice and bold. Hey, how do you like that? Even Mr. Anderson makes mistakes once in a while. Not too often, but once in a while. All right. So now that second equation should come out to be negative 2x plus 2. Now, what happens is you need to graph those two equations on a graph that looks like this one right here. You'll notice, whoops, didn't mean to do that. Let me kind of go back on that for a second. Okay. You'll notice there's a blue line. The blue line goes with the top equation, always. And there's a red or a pink line, and that line always goes with the bottom one, always. So you can see when I simplified this one, I did it in blue. And when I simplified this one right here, I did that one in kind of that reddish pinkish color right there. Okay, so I'm going to take and I'm going to graph these two lines. So first I graph the blue line. So I start at negative 4. So start at negative 4. And then my slope is 2, which means up 2 over 1. Remember, I could put this as a fraction, 2 over 1, meaning up 2 over 1. So I plot the blue line first. Then I've got to plot the red line, the second line. So the blue line was already done. I now plot the red line. I start at positive 2 right here, and then I go down 2 over 1, so down 2 over 1, and that is the graph. Now the question is, how many times do these lines cross each other? If you said, I only see them crossing one time, you'd be correct. So this is an example of exactly one solution. The two lines cross one time, okay? So that's how you do that. I'm now going to get rid of this thing. Oops, why am I not able to get rid of that thing? Oh, where'd you go? There you go, now I got rid of it. Now, before I just give, oh, here, now I can keep this answer up here. This is no big deal. On this second one here, y equals 3x plus 2, again, this would be the blue line. We start at positive 2, so I put my dot on the positive 2. My slope is 3 over 1, which means up 3 over 1. For my red line, I'm going to start at negative 6. So I start at negative 6, up 3 over 1. What do you notice about these two lines? Okay, they're what to each other? Hopefully in your mind you just went they're parallel to each other, which means how many times will these two lines cross? Hopefully you said they'll never cross. They're parallel. Parallel lines never touch each other. And that's correct. So that means there are no solutions, meaning the lines will never cross, ever, ever, ever. Okay, third one. Uh-oh, do you notice that these are in that standard form again where the x and the y's are on the same side? So you need to do your work to convert them into slope-intercept form, convert them into this format right here. And so I've done that work right here. And dang, what do you notice about both of those equations? They're both the exact same equation. I know, it's kind of weird, isn't it? So we're going to graph both of them, both the blue and the red line. I've graphed the blue line first right here, start at -4. I go down 4/3. Then I put the red line there. I start at -4. I go down 4/3. You'll notice the red line, because it's on the top, is the color that shows up. Notice that these two lines created one single line, meaning they're the exact same line. They cross here, 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 here. They cross infinite number of times all throughout this line, going on forever and ever. So these lines have infinite number of solutions. Whenever they're the exact same line, they have infinite solutions. So that becomes our answer right there. Okay? This is how you do today's con. Number of solutions to a system by graphing them. So you're going to make sure they're first in y equals mx plus b format. Then you graph the lines, and then you tell me how many times they cross. 1 time, 0 times, or infinite number of times. Hopefully that makes sense, guys. Good luck today. Bye-bye.